Okay. Solving equations with fractions and decimals. So a lot of you mentioned that the equations with fractions were tricky. So let me give you some help there. There's a way to make it a lot easier. Okay. Solve each of the following. So we're on page 122 in your book. So please get out your book and take some notes in your book. It's good to have practice problems written out in a place you can find. So we're starting with A, and we have 2x plus 0.4 is equal to 18. Now this one does not have a fraction, but it does have a decimal. And decimals aren't that big a deal, especially when you have a calculator, but you don't have to have decimals in your problems if you don't want them there. So hopefully everybody can see that I have 3 terms. I don't have any subtraction, so I don't need to worry about that. But if I don't want a decimal here, what I'd like to do is shift the decimal one place to the right, and instead of 0.4, make that a 4. And I can do that. I can shift the decimal any way I want just by multiplying by factors of 10. Does everybody agree that if I multiply 0.4 by 10, it's going to shift the decimal and I'm going to end up with 4.0 instead? And now you got to remember our rule. Whenever we multiply an equation by a factor, we have to multiply every term both sides. So, come on, pen. So 2x times 10 would be 20x. 0.4 times 10 would be 4, not 40, right? It's shifting the decimal one place over. The decimal's here now, so that's 4.0, which is just 4. And then 18 times 10 is 180. And now I can happily finish my problem without any decimals to trip me up. I can see here that I have 4 positive ones on the same side of the equal as the equal sign as the variable, so I will add 4 negative ones to both sides. The colors are not easy to do here. I might have to forego the colors for you guys. I hope you can still follow along. So these 4 positive ones eliminate these 4 negative ones, and I get 20x is equal to 176. And then I've got 20 times x, so I'm going to divide the inverse of multiplying. I've got a 20 I want to cancel out, so I can keep the x but just cancel the 20. To cancel a 20 in the numerator, I need a 20 in the denominator. Cancel those 20s out, and I get x is equal to 176 divided by 20. And I will break out my handy calculator. 176 divided by 20 is 8.8. It is fine to have a decimal in your answer because there was a decimal in your problem. You guys got it? All right, let's look at B. So for problem B, we've got negative 1/3 x. I'm going to change this to plus a negative 4 is equal to 12. All right. I heard from a lot of you that you don't like fractions in your problems. The first thing I would do is multiply this fraction times this variable, right? Just put the x over 1, multiply numerator times numerator. Negative 1 times x is negative x. Multiply denominator times denominator. 3 times 1 is 3. You don't have to do that, but I like it. The next thing I'm going to do is instead of adding 4 to both sides, I'm going to say death to all fractions. I do not like fractions. I never want them. The very first thing that I'm going to do is get rid of them. And you can do this on every single problem as your first step. Can be get rid of all fractions. And then you never have to do a problem that has fractions in it ever again. Doesn't that sound appealing? So I have a 3 in the denominator, and I don't want it there. So if I multiply this by a factor of 3 in the numerator, they will cancel, right? But if I multiply one term in my equation by a number, I have to multiply every term in my equation by that same number. That's the thing you got to remember. That's the cost. The benefit is that we can cancel those 3's and I get negative x. The cost is I have to remember to multiply that same factor of 3 times every term. So negative 4 times 3 is negative 12. 12 times 3 is 36. Oh, and now I've got 12 negative ones, so I'll add 12 positive ones to both sides. This positive 12 and this negative 12 eliminate each other. I get negative x is equal to 48. I don't want a negative x, so I'm going to take the opposite of both sides. Woo! Flip it over. The opposite of negative x, positive x. And if I take the opposite of that side, I'll take the opposite of this side. The opposite of a positive 48, negative 48. All right, last one is C. 1.5 is equal to 5x. Instead of minus 2, I'm going to write plus a negative 2. Okay, I don't want a 1.5. I'd like no decimals at all. So I will multiply by 10. Multiplying by 10 will shift that decimal one place. That's all it's going to take to make this 1.5 into 15. So let's multiply by 10. If I multiply this term by 10, I multiply every term by 10. And that's going to give me 15 is equal to 50x. 5x times 10, 50x. 10 groups of 5x, 50x's. And then negative 2 times 10 gives me negative 20. All right, no decimals, and I can just solve to my heart's content. To get rid of these 20 negative ones, I shall add 20 positive ones to both sides. I shall try. There we go. So these eliminate each other, and I get 50x is equal to 35. Then I'm going to divide both sides by 50, because x is multiplied times 50. The inverse is dividing. And then this 50 and this 50 can cancel each other. Remember, you need a 1, not a 0 here. Because 1 times x is x. 0 times x is 0. You would have nothing. 35 divided by 50, I'm going back to my handy-dandy calculator, and I got 0.7. And again, a decimal in your answer is fine because there was a decimal in the original problem. Let's try another one. Kathleen is spending summer vacation hiking in Canada and wants to dress appropriately for the day's hike. The local news reports that the high temperature is expected to be 20 degrees Celsius. Oh, Celsius. We don't do Celsius. So there's a formula, and this is it, where we can convert Celsius to Fahrenheit. This problem is kind of lame because you're just plugging in and simplifying. This is more of an order of operations problem. So I'm going to change it to make it a little harder. I'm going to say that your friend is visiting you from Canada and found out that it was going to be 57 degrees Fahrenheit today. How many degrees Celsius is it? Okay, we can use the same formula to convert to Celsius. We're just going to take this formula. F is equal to 9 over 5 times C plus 32. And then we're going to substitute 57 for F. So instead of F, I'm going to have 57 because F represents the number of degrees Fahrenheit. 57 is my number of degrees Fahrenheit. Is equal to 9/5 C, or I would say 9 times C over 5. By just multiplying these together. 9 times C is 9C, 5 times 1 is 5. I like that better. I know some people don't. Okay, perfectly fine equation, except for that 5 in the denominator. Ew. But we don't have to have things in the denominator anymore. We figured out the trick. If I don't want a 5 in the denominator, I will multiply a 5 in the numerator to cancel it out. But if I multiply this term by 5, I have to multiply every term by 5. All right. 57 times 5 is 285. This 5 cancels this 5, and I get 9c, and 32 times 5 is 160. And there you go. A problem with fractions turns into a problem without any fractions. To get rid of this positive 160, I will add a negative 160 to both sides. I'll put it underneath this time because I'm running out of room over there. So I get 9c, 285 minus 165 to 125. Divide both sides by 9. And I get c is equal to, well, a whole number is not really appropriate here because it's temperature, or I mean fraction. Even though this is a simplified fraction, it's no good for an answer for what's the temperature today. 125 ninths does not tell me how I should dress. Is that cold? Is that warm? So it turns out to be 13 and 8 ninths if you change it into a mixed number or mixed fraction. So 13 and 8 ninths. So 57 degrees Fahrenheit is chilly, right? It's sweater weather for us. In California, we say that's downright cold. In Canada, they'd probably be like, no, that's pretty warm. But if you were looking at it in Celsius, it would be almost 14 degrees Celsius. All right. I'm not going to do this one. Too easy for you. I'm going to do number 10. Number 10, we have 5 halves y is equal to 10. So I can multiply 5 halves times y and get 5 times y over 2 is equal to 10. And again, every time I have a fraction, I always have the ability to get rid of that fraction by just multiplying every term by the number in the denominator as my very first step. Not later, but right now as my very first step. 2 divided by 2 is 1, and I get 5y is equal to 20. Divide both sides by 5, and y is equal to 4. Okay? And then number 11, I'm going to squeak 11 in right here. 0.3p plus 1.75 is equal to 6.25. Again, decimals, if you don't have a calculator, decimals are a little bit of a pain, especially if you're dividing or multiplying by them. So we can clear all these decimals out. But 10 isn't going to do it for us. Because in order to turn this into a whole number, I've got to scoot the decimal 2 places. Agreed? 2 places. Same thing for the 6.25. So I'm going to multiply times 100. Every term, both sides. Always has to be the exact same number times every term on both sides. All right, so 0.3p times 100. 100 is going to scoot the decimal 2 places, which is going to give me 30p. Here it scoots the decimal 2 places, so that's 175. And here it scoots the decimal 2 places, so that's 625. And now I have a perfectly fine equation that has no decimals in it. So let's get rid of this 175 by adding negative 175 to both sides. So this term and this term eliminate each other, and I get 30p is equal to 0, 5, 4, right? I'm pretty sure it's 450. Divide both sides by 30. 30. So p is equal to, well, every time there's a 0 at the end, that's times 10, right? So these would cancel. And 45 is 9 times 5, which is 3 times 3 times 5. So that 3 cancels, and I get 3 times 5, which is 15. So my answer is 15. All right. Let's take a look at this one. We're on page 123 now, problem number 15. Again, we have a fraction. And again, we are going to totally get rid of that fraction as our very first step. There is no problem that has a fraction in it that you can't use this trick on. It always works. So I have only one term here. I hope you see that. And this term has a 7 in the denominator. So I'm only going to multiply 7 once. Don't multiply 7 times each term inside the parentheses. We're looking at the whole thing. This is one term, so I multiply it by 1 7. And if I multiply this side by 7, I'm going to multiply this side by 7. So my 7's cancel. And I get x plus 2 is equal to 98. I don't need these parentheses anymore because there's nothing on the outside. So I can add a negative 2 to both sides, and I get x is equal to 96. No problem. All right, so we've got these, which is a lot. We're not going to do all of them, but I did want to do A for you, so let's do A. First thing I'm going to do is rewrite it without subtraction. Equals 6x plus negative 9. All right, I've got this 2 in the denominator and I don't want it. I am going to want to circle my terms though, because I have to multiply. Oh, come on. I have to multiply every term by 2 to get rid of that 2 in the denominator. So I best know how many terms I have, right? So those are all the terms I need to multiply times 2. Does everybody see why I want to multiply times 2? I don't want this 2 in the denominator. So I'm going to multiply this entire term times 2, which means I'm going to multiply this term times 2, and I'm going to multiply this term times 2, and I'm going to multiply this term times 2. Multiply every term times 2. So 2 times 2 is 4. That's my new term. This 2 in the numerator cancels this 2 in the denominator. Don't lose that negative there. And I get negative 3 times x plus 1. 2 times 6x is 12x. And negative 9 times 2 is negative 18. And already, that problem doesn't look as bad. Now that I've gotten rid of my fractions, I do want to also get rid of the parentheses. So we're going to use a little distributive property here. So I have 4 plus negative 3 times x is negative 3x. Negative 3 times positive 1 is negative 3. And then I have 12x plus negative 18. Hopefully you can see that these are like terms. 4 positive 1s, 3 negative 1s. I can add those together and get 1 positive 1. And now I have cleared out my fractions. I have simplified both sides. I am ready to start solving. And the first thing I'm going to be laser focused on is the fact that I have terms with a variable on both sides of the equal sign. That's what I need to deal with first, and then I can isolate my variable. So you could either add a negative 12x to both sides or add a positive 3x to both sides. I am going to choose the positive 3x. You just want to eliminate one of those terms. So 3x, 3 positive x's plus 3 negative x's are going to add to 0. They eliminate each other, and the only thing on this side of the equal sign is that positive 1. 12 positive x's plus 3 more positive x's gives me 15 positive x's altogether. And we have that negative 18. Oops, x's. If your variable disappears, you've done something horribly wrong. Start over. You can never recover if their variable is gone, because the whole point is to isolate the variable. So I'm going to add 18 positive ones to both sides to get those 15 x's all alone. So 18 negative x's, 18 negative ones, 18 positive ones eliminate each other. So I got 15x is equal to 18 plus 1 is 19. Divide both sides by 15. And my answer is going to be x is equal to 19 over 15. Can I simplify that? No. 19 is prime, right? And 15 is 3 times 5, so nothing's going to cancel. That answer is fully simplified. Let's look at E, shall we? Oh, hold on. I think I've got, oh, look at that. It's right there. So for E, we've got 1/2 times 18x minus, we're going to change it to plus a negative 8, equals 6x plus negative 7/2. Wow, that looks intimidating. But I know I don't have to have any fractions if I don't want to, and I don't want to. So this is all one term. I hope you see that this is all one term. So since this whole term has a 2 in the denominator, I'm just going to multiply that whole term by 2, but just once. This is a term, 6x, so I'm going to multiply it by 2. And negative 7/2 is a term, so I'm going to multiply it by 2. And doing that means that all of my denominators are going to cancel. 2 divided by 2 is 1. And since this was just a 1 now, 1 times 18x plus negative 8 is going to be 18x plus negative 8, right? There's no distributing a 1. This just says a one group of 18x's and 8 negative 1's. Here I have two groups of 6x or 12x's. And here the 2 in the denominator and the 2 in the numerator cancel and I get negative 7. Isn't that nice? So we went from this ugly equation with all these fractions in it to this equation, which isn't so bad. Now I do have variables on both sides of my equal sign. And that's something I'm going to have to deal with, and I'm going to have to deal with it first. So I could add 12 negative x's to get rid of this term, or I could add 18 negative x's to get rid of this term. I like to keep my variable term positive, so I'm going to add 12 negative x's. Oh, that's too faint. I'm going to add 12 negative x's to both sides. So these 12 positive x's and these 12 negative x's, they eliminate each other. 18 positive x's plus 12 negative x's gives me 6 positive x's. And those 8 negative 1's. All right, now that I have all my variables on one side, I can worry about isolating the variable, getting this x by itself. So let's add 8 to both sides. So negative 8 plus positive 8 eliminate each other. So I get 6x is equal to 1. Negative 7 plus positive 8 is 1. Divide both sides by 6. And I get x is equal to 1/6. Okay, are they getting any easier? I have a lot of students who really love this trick. In fact, one student even said, so you're telling me if I had like a fraction problem, I could just multiply every term and get rid of the denominators and not do the fraction problem? Yes, that is a true statement. But it does bring up the question of what if the denominators are not the same? They're not always going to be the same, right? So what would I do for this problem? This is on page 125. It's part of a word problem example, but we're just going to deal with the solving of it, and we'll deal with the fact, setting up the problems from word problems we're going to do in our next unit. All right, so I've got, well, let's do this. I've got 4 terms. 1, 2, 3, 4 terms. Agreed? 2 of them are fractions. And the fractions do not have a common denominator. So the first thing I'm going to do is I'm going to multiply. 1 times p is p. 3 times 1 is 3. So it's super clear what my denominators are. I don't know why they put feet in here. Never put your units inside your equation. That's just asking for trouble. So I'm just going to write this as a 30. 1/4 p, I'm going to multiply 1 times p and get p in the numerator, 4 times 1 and get 4 in the denominator, and then plus 60. So I would like to get rid of my fractions, but they're not the same number. In order to cancel this 3 in the denominator, I'm going to need a 3 in the numerator. And I know I have to multiply that times every term, even though it's not going to cancel this denominator for me. So this will get rid of this 3, which is great. But it's not going to get rid of the 4. But that's okay, because I can just multiply every term times 4. Yeah. Just multiply by whatever you need to multiply to get rid of those denominators. You can multiply as many numbers as you want, as long as you multiply them times every term. So in this term, this 3 and this 3 cancel each other, and I get 4p. In this term, I get 30 times 3 times 4. Well, 30 times 3 is going to be 90. 90 times 4 is going to be 360. Here, the 4 in the numerator and the 4 in the denominator cancel each other, but I still have 3 times p, so that's 3p. And here I have 60 times 3 times 4. Let's see, 60 times 3 is 180. 180 times 4 is 720. So this is 720. And now I have an equation with no fractions in it, which is less intimidating and easier to solve. I am noticing that I have variables on both sides of the equal sign, so I'm going to have to deal with that first. I'm going to get rid of these 3 positive p's by adding 3 negative p's to both sides. So these positives and these negatives eliminate each other. Same quantity, opposite signs, always eliminate. And I just get 720 on this side. 4 positive p's plus 3 negative p's are going to eliminate, and I'll have 1 positive p left, plus 360. All right, I just have to get rid of 360. I can do that by adding negative 360. So these 2 terms eliminate each other, and there's the bell. And I get 360. 720 minus 360 is 360. And that is my answer. All right, hopefully this was helpful. I'm going to give you a chance to ask some questions, so let me know what you need to practice. Have a lovely day.